Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue talking about stream I/O, and in particular we're going to look at how we can do buffering on streams. And in doing so we're going to talk about how we can decorate streams to get additional functionality. So if we go to the API, remember everything that we're doing here, we're working with the java.io package, and there are a number of different classes inside of here. We started talking about the input stream and the output stream, and we said that these are abstract. So for example, an input stream has the ability to read, but it doesn't know what it would read from. It's basically just specifying some functionality in order to be able to read stuff. A file input stream is a subtype of input stream. It inherits from input stream, but it actually knows what it's reading from, because when we create it, we give it the file that we're supposed to read from. Now, the input stream itself is fairly simple. It just has a few methods. It just reads bytes, and it pretty much reads them one at a time as needed from whatever source we're pulling from. And so far, our only source has been to pull from a file. A lot of times we'd like to add some additional functionality to this. Now there are different ways that you could do that, and the way they decided in the Java libraries to do this was to use something called the decorator pattern. Okay? And it allows us to take an input stream and wrap it inside of another input stream, and the same thing with output streams. And this wrapping is generally used to either provide some to change the behavior of how things are read or written, or to provide additional functionality. So you might wrap it inside of another class that it will also be an input stream. It will be one of these other input streams that's listed over here, but it will be an alternate input stream that has additional methods in it. Now the first set of input streams we want to talk about here actually don't provide any additional methods. They just make it so that it's more efficient. And so in particular I want to show you how we can use a buffered input stream. Once again, this buffered input stream, it winds up inheriting from the regular input stream. There's also a filter input stream in between here. And it has the same methods that you expect from a normal input stream. Okay, these are the ability to just read data in byte format. But note the constructors here. When we build a buffered input stream, we have to pass it some other form of input stream. Because unlike the file input stream, whereas the file input stream said, I'm going to read from a file, buffered input stream could be reading from pretty much anything. And what it's going to read from is this input stream that you pass in. Now, why would you want to do this? Because we didn't get any extra functions and we're just reading from some other input stream which we were able to read from itself. The reason for using a buffered input stream is for efficiency. Okay, so normally if you read a byte, it goes off and it executes the code to read one byte and gives that byte back to you. In a buffered input stream, if you tell it to read one byte, it will keep a buffer. And so let's assume you've just started reading. The first time you go to read, it says, okay, and it goes out, let's say this is to a file, and it will read in a bunch of bytes, 1,000 or more bytes, who knows. In fact, on the second constructor you can tell it how big of a buffer you want, but it will read in a big chunk of data all at once, and then it will give you the first byte from that. And then when you call read again, it will give you the second byte from the buffer. It doesn't actually go and read from the source. And then the third byte from the buffer and the fourth byte from the buffer. After you've read however many times, however big the buffer is, you run out of buffer, so you call read and it goes and it says, oops, we've run out of space in the buffer, so it reads another really big chunk. And the reason you would want to do this is because a lot of the things that you can read from, or turns out writing from is the same, are fundamentally slow to do, especially in small units. It is very inefficient to read from a file one byte at a time. So instead, we take the input stream that we want to read and we wrap it inside of a buffered input stream. So if we were to come here with this do with file input stream, I'm going to change this a little bit. So it turns out that my the way we've written this code right here, it didn't have to be a file input stream. It would work with any input stream. And so I want to take this file input stream and I want to wrap it inside of a buffered input stream. And I will have to import that. New buffered input stream. Did I? Oh, save. Okay, there we go. I thought I'd hit save. So this takes the file input stream is attached to the file and it has the ability to read bytes, but we've wrapped it inside of this buffered input stream so that whatever body does when it goes to read stuff, it won't read it one byte at a time, pretty much no matter what. It will read it in larger chunks that will wind up being more efficient. Now, if we're reading a small file, this doesn't matter too much, but it really can have a significant impact. In fact, I strongly recommend that you wrap pretty much every stream you ever use in a buffered input stream or a buffered output stream. And the reason I feel this way comes from a story I like to tell my students. I actually had the experience where I wrote a program and it was doing some, it was reading specially formatted files and it was allowing the user to type in specially coded formats. So it was fairly complex code, but I had written it in such a way that I thought that it would work quickly. Okay? And so after I got it to compile the first time and I was able to go and run it, I pulled in a file. I don't know, it was a few megabytes, so it wasn't a tiny file, but it wasn't huge. It wasn't like a 3 gigabyte file or anything like that. Occasionally in my research I'll get multi-gigabyte files, and yeah, those are not really fun to work with, but this is only a few megabytes. And I started the code running on it, and it didn't finish immediately, so I went off and I did something else. And I came back, I forget, 30 minutes or an hour later, and it was still going. And this was not going to be fast enough. This was code that needed to be able to read this in seconds, maybe a minute. Users would probably get upset if it took much longer than that. So I stopped it and I went through that code with a fine-tooth comb looking for what could possibly be slowing it down. And then finally I noticed that I was reading directly from the file input stream and I hadn't wrapped it inside of a buffered input stream. And so I did that. This was, of course, 8, 10, 12 hours later after I had been going through the code. I decided to take and wrap it inside of a buffered input stream, and I ran it, and the thing loaded in a fraction of a second. Okay, so the speed benefit that you can get of using a buffered stream as opposed to reading individual bytes if you do it directly from something like a file input stream can be tremendous. Some of these things will be implementation dependent, they'll be hardware dependent, but the bottom line is I have come to appreciate the fact that you should always wrap your streams so that they are buffered, unless you just know for certain that you're always going to be reading teeny tiny files. If there's any chance that you're going to have a reasonable sized piece of data, you should wrap it in this way. Okay, so this is your introduction to the wrapping of streams, and what this is called the decorator pattern, because we've decorated our file input stream with the buffering functionality, and now we have a new object that reads from this, but it does it with some additional features. And we've talked about the fact that buffered streams can give you superior performance for working with stuff. So we'll come back in the next video and we'll look at a different type of decoration which will actually provide additional methods for us.